In an architectural Revit model, the architect uses a room object. These elements describe a room in a building and have many parameters describing a room that are really of no interest to the MEP design team. The way Revit MEP deals with this is with the space object. A space element has analytical parameters such as average estimated illumination, supply airflow, and design cooling load. An MEP space object is totally separate from an architectural room object. It is created, named, and controlled entirely within the MEP model. Sometimes, the mechanical designer will split up a large area that the architectural team has defined as a single room into multiple spaces. This might happen for large corridors or open office suites. A space element is essentially a database or container for mechanical and electrical analytical information. Let's take a closer look at what information is included within a space. In this model, there is one space created, Space 1. I'll select this space. Realize that the reference lines and interior fill for the space have been turned on. If they have not been turned on, you can select the space by moving the cursor around the space tag or exterior boundary until the space reference lines highlight. Once they do, click to select the space. Looking in the Properties palette, we can see all the instance properties for a space. There are approximately 40 parameters for a space, and they are all instance properties. As you can see, the Edit Type button in the Properties palette is not available. Also, note that a space has other envelope information associated with it as well. This information is not visible to us in the Properties palette, but is instead part of the heating and cooling load calculation engine. As you can see, numerous fields are read-only and are grayed out. These fields are not editable by the user, but they are instead calculated, or they reference other parameters in the model. In some cases, these parameters are populated by external analysis engines. All of these fields are significant, and it is important to understand each one. Let's start in the Constraints section. The level indicates the base level at which the space is located. The upper limit is the top level of the space. This can be the same as the level, and then you can specify a limit offset to change the height of the space. You can also use the base offset parameter to change the base elevation of the space. These parameters help define the vertical limits of the space and also control the volume of the space. These parameters are very important when you are working with the Revit load engine or exporting a GBXML file. If you are using Revit to help with HVAC loads or energy analysis, a space must fill the entire volume of the building to get accurate results. You can have the space extend to the next level or just to the ceiling, and then create another space for the plenum area. Either way, you want to have spaces fill the entire volume. In the electrical lighting section, the average estimated illumination is calculated based on the amount of light from each fixture and the area of the space. The room cavity ratio is also calculated based on the room cavity height, lighting calculation work plane, and lighting calculation luminaire plane. The lighting calculation work plane is the next parameter and is simply the level used as the base for calculating illumination. The lighting calculation luminaire plane is the height of the light sources in the space. Since there are not any light fixtures placed in this space, the parameter is not computed, and therefore the other calculated parameters are 0. The room cavity height, which is used to calculate the room cavity ratio, is a parameter not shown here. It is simply the lighting calculation luminaire plane minus the lighting calculation workplane. The other parameters in this section are reflectance values for the ceiling, wall, and floor. These values can be specified based on the color and surface of the ceiling, walls, and floor respectively. Take note that if the lighting fixtures are placed outside the space, these values will not be accurate. In the electrical load section, you can specify the design HVAC load per area and design other load per area for heating and cooling load calculations. These values can also be calculated by the Integrated Heating and Cooling Loads Analysis tool or read from a GBXML file. In the mechanical flow section, you can enter the specified supply airflow. The calculated supply airflow is the total airflow required to heat and cool the space. It can be calculated by the Integrated Heating and Cooling Loads Analysis tool or read from a GBXML file. Then, once air terminals have been placed in the space, the actual supply airflow is calculated based on the sum of the airflow for all supply air terminals. When you click in the Return Airflow Value field, you can expand the drop-down and select one of the following options to determine how the return airflow is calculated. Specified activates the specified return airflow parameter, and then you can enter the return airflow. If you select any of the next three parameters, specified, calculated, or actual supply airflow, the return airflow will match that value for the supply airflow. The actual return airflow is calculated based on the sum of the airflow for all return air terminals placed in the space. Lastly, you can enter the specified exhaust airflow for spaces needing to be exhausted, and then the actual exhaust airflow will be calculated based on the exhaust air terminals placed in the space. In the Dimensions section, all the values are calculated and read-only. The area and perimeter are computed based on the room bounding elements. The unbounded height is the largest potential height of the space, based on the space height parameters in the Constraints section. The space's actual height may vary depending on the room bounding elements, such as intervening floors and roofs. Next, the volume is calculated based on the area and height when volume computation is enabled. The computational height is the distance above the base level that Revit measures the perimeter of the space. It is used to compute the perimeter, area, and volume. In the Identity Data section, you can enter a number and name for the space. The space number must be unique for each space in a project. When creating spaces based on architectural rooms in a linked model, the room number and room name will reference these parameters in the architectural model. These parameters are very useful when you want to tag the space based on the architectural names and numbers. Then you don't have to worry about matching the space name and number to the room name and number. Also, you can enter any additional information in the comments field. In the phasing section, the phase of the space is shown and is read-only. The phase of the space is based on the view properties for the view in which the space was created. Finally, in the energy analysis section, there are several more parameters. The zone parameter reports the HVAC zone in which the space is part of. You can also select whether or not the space is occupiable, and if it is a plenum. The condition type parameter determines how heating and cooling loads are calculated, and can be set to heated, cooled, heated and cooled, unconditioned, vented, or naturally vented only. When you click in the Space Type field, You can click the button to open the space type settings dialog. Here, you can specify the space type. I'll click Cancel to close the dialog. Similarly, you can click in the Construction Type field and click the button to open the Construction Type dialog to select the construction types for the various categories. Once again, I'll click Cancel to close the dialog. Additionally, both of the edit buttons for people and electrical loads open dialogs which allow you to control how these loads are calculated for the space. The calculated heating load and calculated cooling load can be calculated by the Integrated Heating and Cooling Loads Analysis tool, or read from a GBXML file. And the design heating load and design cooling load can be specified, calculated, or read from a GBXML file. All of the available parameters can be used in schedules or in tags.